We are now going to take a look at what the point on the unit circle is at 45 degrees. So give me a second, I'm going to sketch this triangle. I'll be right back. Alright, so here we have our point at 45 degrees, and again we draw a triangle to figure out what this point is. We can see that the x value is going to be equal to the length of the base of this triangle from the origin, and the y value is going to be equal to the height. Again, we're going to start out with simplicity's sake and just say that the radius is 1, but again later on we'll label it as r and see how that affects our point. So we just need to figure out the x and y values of this point. I'm going to go ahead and just put a blank space here. You'll notice 45 degrees is a special angle, and we learned the trig functions at 45 degrees. So first off, to figure out the x value, since x is the adjacent side, okay, then we can use cosine, since cosine is adjacent over hypotenuse, to figure out what this point is. Now if you remember, going back to our lesson on 45 degree trig values, we have cosine of 45 Now remember, the definition of cosine is what? Adjacent over hypotenuse. So if you take a look at this triangle, okay, please stop moving, that'd be great, thank you. This would be the adjacent side, and this would be the hypotenuse, and we can see, again, adjacent side just going to be whatever this x value is of this point right here. So we're going to write it as x over 1 for cosine of 45. Now if you notice a trend here, we always have 1 on the bottom whenever the radius is 1. So basically you can kind of start to see this identity. Cosine is always just going to be the x value, and vice versa. The x value will be the cosine of that angle, just because you're dividing by 1 and it won't matter. When you divide by 1 it stays the same, right? So real quickly, cosine of 45 is square root of 2 over 2, or as we said before, about 0.7, and since it's x over 1, that's just going to be your x value, square root of 2 over 2. So we can go over here to our point and label the x value of our point square root of 2 over 2. Again, that's about 0.7. It means that this side right here is about 0.7, again assuming that the radius is 1. Makes sense. Not quite as big, but about 70% the size. So what about the y value? Well, I'm not going to spend a lot of time on this one because we can already see that this is a 45, 45, 90 triangle. And if one side is square root of 2, meaning the bottom side, square root of 2 over 2, then that must also be square root of 2 over 2. We could use sine to prove that. But that's really all you have to do here. So there's your point on the unit circle if you go up 45 degrees from your starting point. Let me use a different color here. So if you go 45 degrees from the starting point, remember the starting point is actually there at 0, 1, or sorry, 1, 0. If you go 45 degrees up from that, that point on the unit circle is square root of 2 over 2, square root of 2 over 2. Now real quickly, let's kind of change this real quick. I'm just going to delete a few things, delete this and change it to r. So again, the unit circle, technically the radius can be whatever it wants to be, and again the reason for that is in order to apply the unit circle to the real world, we can't just assume everything has a radius of 1, right? Circles vary in size. So the question is, what happens to this point when we change it to r? Well, let's just go back to the cosine example, okay? Cosine of 45. In fact, we'll just change it, and again, this is just going to save some time. So instead of it being 45, cosine of 45 equals x over r, cosine of 45 equals x over 1 is going to be cosine of 45 equals x over r. And remember, in this case, in order to get r by itself, you would have to multiply both sides of the equation by r. Well, actually, let's just change that a little bit. I don't want to confuse you. Let's do it down on the next. So we still have an x, let's make it pink. Okay. We still have cosine of 45 equals x over r. but cosine of 45 is square root of 2 over 2. In order to get x by itself, you'd have to multiply both sides by r. You can start to see that when you make the radius r, your answer is just going to be, for your x value, is just going to be cosine of that value times r. So in this case, you'd get square root of 2 over 2 times r equals x. This will work for any angle, and we're going to see that as we move on to 60 and 90 and whatnot, 120 even. You just find the cosine of that angle and multiply it by r to give you your x value. So if we go back and actually look at this point, technically, with the radius of r, the answer is going to be square root of 2 over 2r, and the same thing is going to happen for sine. It's also going to be square root of 2 over 2r. So you can start to see what these points on the unit circle look like. Now again, to add clarity, what does this actually mean? Because this looks kind of complicated. Well, if we pull up our calculator, which I will, let's see what square root of 2 over 2r really looks like. Actually, we can just, I know what square root of 2 over 2 means. We'll just rewrite this point as a decimal. Square root of 2 over 2 is actually 0.7. So it's really around 0.7r, 0.7r. Alright, this point right here. Okay, and so what that really means is, let's just say the radius was 10. Okay, so let's just say that this right here was 10 meters long. Okay, what that really means is this would be 0.7 of that, so about 7 meters long. Same for this. That would be about 7 meters long, be 0.7 of that. So that's just a more concrete way of thinking about square root of 2 over 2r as a point. Your point would look more like that, and it helps even more to think about the radius as an actual number. So that's it for your point at 45 degrees on the unit circle. If you have any other questions about this lesson, let me know.